All right, this is section 8.6 video notes, and it's over solving rational equations and inequalities. So let's just first look at our objectives. So basically we're going to solve a rational equation and a rational inequality. We've got three vocabulary words, a rational equation, weighted average, and rational inequality. So let's get straight to the book and start this section. So what is a rational equation? It's an equation, which means you have an equal sign with one or more rational expressions. So you have one or more term that's a rational expression. We already learned what rational expressions are. Now, in order to solve these equations, the easiest way to do is get rid of the denominator by multiplying each term, or in the entire equation, by the least common denominator. So let's look at example 1. Okay. Example 1 is going to be 4 over x plus 3 plus 5 over 6 equals 23 over 18. So the first thing is we look at all the denominators, x plus 3 and 6 and 18. We're going to prime factor them out. Okay, 6 is 2 times 3. This is 2 times 3 squared. So I have what? X plus 3 times 2 times 3, and the highest power is this. So 2 times 3 squared is 18, so my LCD is 18 times x plus 3. And I'm not going to multiply that out. So I'm going to take the entire equation and multiply by 18 times x plus 3. That means I have to distribute to each term of the equation, which I have a total of 3. When you multiply 4 over x plus 3, well, we already did these in a section before. Doesn't this cancel out? I'm just left with 4 times 18, which is 72, plus, if I multiply this times this 6 cancels out, and this becomes 3. So this becomes 15 times x plus 3 equal, the 18s cancel out, so then I just have 23 times x plus 3. Now I've got to distribute all this. So I have 72 plus 15x plus 45 equal 23x plus 69. Now I'm just going to use algebra. Since I don't have a lot of room, I'm not going to do everything here. So I end up getting, when I do the algebra, I get x equals 6. But I must put it back into the original equation to make sure I don't have what? Extraneous solution. Because when we multiply with the LCD, it can result in a false solution. So we have 15 over 6 equal 23 over 18. Common multiple is 18, so this becomes 8. This becomes 15, and 23 over 18 does indeed equal 23 over 18. All right. So let's look at example number 2, which says, whoops. Okay, so again, you have to be careful. So let's look at this example. I'm not going to, so let's go back here. And first thing we're going to do is we're going to get an LCD. So I'm going to take, I have x plus 5 as one denominator. I have x squared plus 8x plus 15 as the other denominator, and I have x plus 3. Okay, so this one is factored. This one is factored. Yes? Now this one I need to factor. So when I go and factor this, it's x plus 5 times x plus 3. Okay. So what are we going to do? Oops, this is x plus 5. So how many different bases do I have? I have 2. I have an x plus 5. Remember, this is all one factor. Times what? X plus 3, and they're all raised to the 1. So this is my LCD. So if I take my equation, which was 2x over x plus 5 times x plus 5 times x plus 3 minus x plus 5 times x plus 3. Oh no, I lied. This is x plus 5 times x plus 3, but we are multiplying by that. And then we had x minus 10, x squared minus x minus 10. Okay, equals 3 times x plus 5 times x plus 3 all over x plus 3. I just distributed the LCD. So this and this cancel. This and this and this and this and this and this. So I'm left with 2x times x plus 3. So I'm going to distribute. I'm going to get 2x squared plus 6x minus, so I'm going to distribute 2. This, the only thing left is this. So I'm going to do so is minus x squared plus x plus 10. You have to distribute all the way through. Then I have 3x up to 10. 3x plus 15. All right. So now this is a long problem. So I have to combine like terms. Let me make sure I did this right. Yes. Okay. So combine like terms. So I have x squared plus 7x plus 10 equal 3x plus 15. Now I'm going to subtract this from both sides. I'm not going to, all right, minus 3x minus 15. And then I end up with 0, and I end up with x squared plus 4x plus 5. That factors to x plus 1. Wait, this should be minus 5. I somehow got a sign wrong somewhere. Oh, because it's minus 15. Yes, that's right. So it's x plus 1, no, x minus 1 times x plus 5. When I solve them, I get x equal 1 and x equal negative 5. So can't be negative 5. Why? So we still have to find the restrictions. So remember, the restrictions are x can't equal negative 5 and x can't equal what? Negative 3. When I take all my denominator factors and set them equal to 0, so it can't be negative because it's undefined. So this is my only solution. And I'd put it back in check, and when you put 1 into the original equation, you get a true statement. Okay, so that's how you would do those kind of problems. Now, moving on. So, now we're going to talk about some chemistry. We're going to talk about weighted average. What is weighted average? That's our next vocabulary. Weighted average is just a method for finding the mean, which mean means average, of a set of numbers in which some of the elements set carry more weight, okay, than others. And we use this a lot in mixtures, work, distance, and interest problems using rational equations. So let's look at the first mixture problem, chemistry. So Mia adds 70% acid solution to 12 milliliters of a solution that is 15% acid. How much of the 70% acid solution should be added to create a solution that is 60% added? So first of all, let's understand what's going on. So Mia needs to know how much solution needs to be added to an original solution to create a new solution. But each solution is weighted. So if we go back here and we say the amount of acid, it's going to be what? 0.15 of what? 12 milliliters plus, we're adding 0.7 of some solution amount, X, is going to equal to the sum of these two. Then our solution is going to be what? 12 milliliters plus X milliliters of solution equals 12 plus X. So this is our nu. So remember, when we want to find percentage of acid in solution, it's the amount of acid divided by the total solution. So we can say percent over 100 equals amount of acid over total solution to find the percent. So now we want to create what? We want 60%, right, of the amount of acid, which is this right here, the nu, divided by the total, which is here. So what do we have? We have a rational expression, and we just can do what? We can multiply the entire equation by the LCD, which is 100 times 12 plus X, and then we can solve for X. Our denominators go away. We end up with this equation here. We must simplify, so we have to distribute. I'm just using plain algebra, and we get X equal 54 milliliters. So how do we check that? Well, we put it back into the equation, our original equation, and guess what? 0.6 equals 0.6. Okay, so now let's look at another example of distance. So the distance formula is R times T. So the distance, D is the distance, R is the rate, and T is the time. However, we can change it by using algebra solving for R and T. So let's look at this distance problem. Sandra is rowing a canoe on Stanhope Lake. Her rate in still water is 6 miles per hour. It takes Sandra 3 hours to travel 10 miles round trip. Assuming that Sandra rowed at a constant rate of speed, determine the rate of the current. Okay, so we're given her speed in still water and the time it takes her to travel with the current and against it. So it takes 3 hours to, if we look at it this way, to go and come back, this T plus this T. So we know T1 plus T2 equals what? 3 hours. All right. So that's the total time. What else do we know? Assuming that she rode okay. So we need to determine the speed of the current. So when you're time with the current, okay. So remember the time is what? Distance over rate. Well, we know that this distance and this distance are what? Equal, because she went round trip 10 miles, so therefore this has to be 5 because she went the exact place and back. So we know that time equals distance over r, right? So let's look at this now. So time with current, so distance is 5 for both of these. This is against. So with the current, so we know her at still water, her rate is 6. So if you're going with the current, you're going to add the rate of the current because it's going to make you go faster, right? So 6 plus whatever the current is because she's going with it. When you're going against it, it's going to slow you down. So you're going to minus 6 minus this. So now we have what? This time plus this time equals 3 hours. Okay? Right? So that's what they did. This is time 1, and this is time 2. So now we can solve this. We are just getting a common denominator, which is 6 plus r times 6 minus r. And we multiply it by the entire equation. So to this term, and this term. In this term, the 6 plus r's cancel, and you're left with 6 minus r times 5. Here, the 6 minus r cancels, and you're left with what? 5 times 6 plus r. Here, there's something to cancel out, so it's just 3 times this times this. So they FOIL it, distribute the 3, put it all on one side, set it equal to 0. They're going to factor, and we get what? R equals 4 or R equals negative 4. So the original equation, we put 4 in, and we get a true statement. Since speed cannot be negative, we disregard the negative 5. 4. So the speed of the current is what? 4 miles per hour. Okay, so let's look at one more example, and it's a work problem. Okay. All right, so every year the junior and senior class at Hillcrest High School build a house for the community. If it takes the senior class 24 days to complete a house and 18 days if they work with their junior class, how long will it take the junior class to complete a house if they worked alone? So what do we know first? So we're giving how long it takes the senior class working alone when the class works together. So we need to determine how long will it take for the junior class by themselves. So the senior class can complete one house in 24 hours. So that is their rate. So the rate is 1/24 of a house. The rate for the junior class is 1/j. Okay. The combined rate for both classes is what? 1/18. Okay, so we know the senior rate plus the junior rate is going to give me the combined rate. So let's solve this. What's our common denominator? Common denominator is 72j, so we multiply every term by 72j. And this is no fraction, so we end up with 3j plus 72 equals 4j, and j equals 72. So we can substitute it back in and get a true statement, or we could put this in our calculator and find what that value is. Okay, so so let's look at the inequalities, rational inequalities. So here are the steps for solving the rational inequality. So the only difference is now we have an inequality sign. So first of all, we have to state the excluded values for which the denominator is 0. Solve the related equation. Use the values to determine from the previous step a number line of the intervals. So we're going to test the value in each interval. So let's look at this first one. It says x over 3 minus 1 over x minus 2 is less than x plus 4, x plus 1 over 4. Okay, so first thing we're going to do is we're going to get an LCD. So the LCD, first of all, let's find the limitation. So where do you have a variable? Here. So x cannot equal 2. Our LCD is going to be 12 times x minus 2. So we're going to multiply the entire equation by that. So there's 3 terms, we're going to multiply them all by that. And then we just simplify each one. So the 3 goes into the 12 4 times. So you're left with 4 times x minus 2 times x. Here, the x minus 2 cancel out, so it's just minus 12 times 1. Here, the 4 goes into the 12 3 times, and then we have what? X plus 1 times x minus 2 times 3. So we have to FOIL this and then multiply, distribute to 3. So when we simplify, this is what we have. 4x squared minus 8x minus 12 equals 3x squared minus 3x minus 6. So now we're just using simple algebra, moving everything to the left side or one side and equal it to 0. When we do that, we factor it. We get x equals 6 or x equals negative 1. So we're going to make points of these at 6 and -1, and then the excluded value, which is what? X can't equal +2. So we're going to test a point here, 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 and here, between all these lines and outside of them. So when we test the point -3, we get a true statement. When we test 0, we get a false statement. So this one is not a solution, this interval from -1 to 2. We test 4, which is here, we get a true statement. We test 8, which is on this side, and we get a false statement. So our only true statements are what? Between 2 and 6 and less than -1. So our solution is x is less than -1, or x is greater, 2 is less than x less than 6. Okay, so that's what we do. We plot the points in the solutions, and then we test all the points in between the interval. Okay, so we can change this inequality to what? Equal sign. All right, and that should be it. So do the problems, and we'll see you in class.